Your test covers sections 13.1, 13.2, 13.3, and 13.6. Up top, you have your formulas that you need to know and the ones that are going to be given to you. The only problem with this is that the n is equal to top minus bottom should be plus 1, not minus 1. So make sure you make that change on your form. So first thing that we're going to do is we are going to find the sum in the arithmetic sequence that is given to us. We're not finding the first 3 terms and the last 3 terms. We're just finding the sum. So to find the sum, you're going to use S sub n is equal to n over 2 times a sub 1 plus a sub n. This means that you need to find n, you need to find a sub 1, and you need to find a sub n. To find n, we're going to take top, which is 60, minus bottom, which is the 13, plus 1. So that's 60 minus 13 is 47, plus 1 is 48. So n is 48 in this case. Your a sub 1 means that you're going to take that 13 and plug it in for I in negative 3 times I minus 17. That negative 3 times 13 minus 17 should give you a negative 56 for a sub 1. And then to find a sub n, you're going to take the 60 and plug it in for I. So that means you're going to have negative 3 times 60 minus 17. So negative 3 times 60 minus 17 gives you a sub n is equal to negative 197. So you're going to plug all 3 of these numbers into your formula and simplify. So that means you're going to have S sub n is equal to 48 over 2 times negative 56 plus negative 197. Your 48 over 2 simplifies to be 24. Your negative 56 minus 197 gives you a negative 253. So if you multiply these 2 numbers together, you are left with your answer of negative 6,072. For number 2, it tells you to find a sub 47 and a sub n, given that a sub 12 is 13 and a sub 18 is 31 of the arithmetic sequence. We're working with an arithmetic sequence, which means the formula that you want to work with is a sub n is equal to a sub 1 plus n minus 1 times d. First thing we do is to find d. We're going to use the 12 and the 13 as an ordered pair, as well as the 18 and the 31 as an ordered pair, and find d by using our formula to find slope. So that means we're going to have 31 minus 13 over 18 minus 12. The 31 minus 13 is 18, and 18 minus 12 is 6. 6 goes into 18 3 times, so d is equal to 3. We can find a sub 1 by using the a sub 12 is equal to 13, and that just means that we're going to have 13 is equal to a sub 1 plus n, which is 12, minus 1 times d, that's 3. This is then going to simplify to give us 13 is equal to a sub 1 plus 11 times 3, which is 13 is equal to a sub 1 plus 33. We subtract the 33 over to get a sub 1 by itself, and we have that a sub 1 is equal to negative 20. Now that we have a sub 1 and d, we can find whatever term we need to, as well as a sub n. Your a sub n is going to equal your a sub 1, which is negative 20, plus n minus 1 times d, which is 3. A bunch of you got points taken off on your quiz because when you wrote your rule for a sub n, your d term was not in parentheses, which means it didn't represent multiplication. You need to put the parentheses around the 3. You can't just put plus 3. You can't put minus 3. It's got to be parentheses 3, close parentheses. So if you were to simplify this to get a sub n, you would distribute in that 3 to your n minus 1 to get negative 20 plus 3n minus 3, which would then give you a sub n is equal to 3n minus 23. That is part of your answer that it's asking you for. The last thing you're going to find is a sub 47, so the 47th term. So you're just going to plug in the 47 in for n and simplify. The 3 times 47 minus 23 should give you 118 for your 47th term. For number 3, it tells you that you have this geometric sequence of 4, negative 12, 36, negative 108, 324. You're finding the common ratio from it. You remember geometric sequences to get common ratios. It's what you're multiplying the first number by to get the second number. It's the common ratio, which means the same number gets multiplied by each of the terms to get the following. So if we multiply 4 by negative 3, we get the negative 12. Negative 12 times negative 3 is the 36, and so on. So our common ratio, or R, is negative 3 in this case. For number 4, we're writing the first 5 terms of the geometric sequence, with the first term being 3 and our common ratio of 1/5. Your a sub n is going to be 3 times 1/5 to the power of n minus 1. That's your rule. It already tells us that the first term is 3, so we don't need to find that. To find the second term, we can use the a sub n is equal to 3 times 1/5 to the power of 2 minus 1, which is just going to be 3 times 1/5. So that would mean that a sub n for your second term is 3 over 25. Sorry, 3 over 5, not 3 over 25. Your third term, however, if you were to find the third term, you'd have 3 times 1/5 to the power of 3 minus 1, which is 3 times 1/5 to the second power. That's 3 times 1 over 25, which means the third term is 3 over 25. For your fourth term, you're going to have 3 times 1/5 to the power of 4 minus 1. So that's 3 times 1/5 to the third power, which would give you 3 over 125. Lastly, for your fifth term, you're going to have 3 times 1/5 to the power of 5 minus 1. So that's 3 times 1 over 625, which means your fifth term is 3 over 625. Now you could leave it and just circle all of those 5 terms, or you can give it to me as a sequence of 3, 3/5, 3 over 25, 3 over 125, 3 over 625. For number 5, it asks us to use the formula for the general term or the nth term of a geometric sequence to find the indicated term of the sequence with the first term given and the common ratio. So it tells us that a sub 1 is 7 and r is equal to negative 2. So that means your a sub n, or your formula, is going to be 7 times negative 2 to the power of n minus 1. You plug in that 4 for n, and that'll give you your fourth term. So that means that a sub 4 is equal to 7 times negative 2 to the power of 4 minus 1. That simplifies to give you a sub 4 is equal to 7 times negative 2 to the third power, which is 7 times negative 8. And that means that a sub 4 is negative 56. We're doing practically the same thing for number 6. We're given the sequence 6, 12, 24, 48, 96. If we multiply 6 by 2, that gives us the 12. 12 times 2 is 24. 24 times 2 is 48, and so on. So we see that this is a geometric sequence. It also tells us that it's a geometric sequence with a common ratio of 2 and a first term, a sub 1, of 6. If we use the formula a sub n is equal to a sub 1 times r to the power of n minus 1, that will give us our rule, or our formula. So that means that a sub n is equal to 6 times 2 to the power of n minus 1. For number 7, it's giving you 2 formulas and asking you to find out whether it's an arithmetic sequence, a geometric sequence, or neither. If it's an arithmetic sequence, it's asking you for the common difference. If it's a geometric sequence, it's asking for you to state the common ratio. For the first one, you have a sub n is equal to 3n minus 2. If you look back at number 2 from your review that we just did, you'll realize that once you distribute in your common difference and you combine like terms, you're left with a formula exactly like this. So this represents an arithmetic sequence. To tell what your D is, or your common difference, it's always going to be the coefficient of n. So the number in front of n is 3. That means that your common difference is 3. For something like the bottom equation, you have a sub n is equal to 4 to the power of n. It looks like it could be a geometric sequence. However, there's no minus 1 after the n in the power. So that means that this one is a neither. If you had something, let's say a sub n is equal to 6 to the power of n minus 1, that would be a geometric sequence. The reason why this could be a geometric sequence is because your a sub 1, your first term, could be 1, because 1 is not going to change the value of that 6 to the power of whatever. With that, your common ratio, or R, is the base of your power, which would be 6. So again, because that bottom one, that a sub n is equal to 4 to the power of n, is not a geometric sequence, it's because it does not have n minus 1 as the power. It's just the n. For number 8, you are finding the sum of the first 13 terms in the geometric sequence 5, negative 15, 45, negative 135, 405. If you see here, your first term is a sub 1, is 5. So a sub 1 is equal to 5. Your common ratio that's happening here, the 5 times negative 3 is negative 15, times negative 3 is 45, so on. So R is negative 3. You could find n by doing top minus bottom, which we don't have. It would just be 13 minus 1 plus 1, so n is equal to 13. It's going to tell you you're 13 there. Your formula that you're using here, because you're finding the sum, is going to be that s sub n is equal to a times 1 minus r to the power of n over 1 minus r. This is going to give you 5 times 1 minus negative 3 to the power of 13 over 1 minus negative 3. In your denominator, the double negatives turn into positives. That negative 3 to the 13th power you can also simplify, but I'm going to just plug this all into my calculator and simplify. So we're going to have 5 times 1 minus parentheses negative 3, close parentheses, to the power of 13, close your parentheses from that, all over 1 plus 3, which is 4. And that would give us 1,992,905. For number 9, you're finding the indicated sum and using the formula for the sum of the first n terms of the geometric sequence. So this one gives you I is equal to 4, you're going to 15, and the rule 2 times 4 to the power of I. So with this, your n is going to be the 15 minus 4 plus 1. So that's giving you n is equal to 12. Your a sub 1 can be found by plugging the 4 in for I. So that's 2 times 4 to the 4th power. Your 2 times 4 to the 4th power is 512. And then a sub n, you're going to plug the 15 in for I. That's going to get, or no, sorry, you don't need a sub n because this is a geometric sequence. So use your formula that you used on the one before this, because you need n, you need r, and you need a sub 1. Your r is the 4, so you can write that down. So again, we're using s sub n is equal to a sub 1 times 1 minus r to the power of n all over 1 minus r. If we plug those values in, your a sub 1, we said, is 512 times 1 minus r, which is 4, to the power of n, which is 12, all over 1 minus 4. So again, I'm just going to plug this straight into my calculator, so that way it gives me my answer. So on top, 512 times 1 minus, parentheses, 4 to the power of 12, all over negative 3. So this gives us a very large number of 286,331,1360. For number 10, we're finding the sum of the infinite geometric sequence. Infinite, we know that it is because it's got that dot, dot, dot. Another thing that it would tell you is the infinity symbol. So first thing we're going to do is find a sub 1 and r. A sub 1 is the 48. If you multiply the 48 by 1/4, it gives you the 12. 12 times 1/4 is 3. 3 times 1/4 is 3/4. So r is 1/4. Your infinite sum formula, you have S sub n is equal to a sub 1 over 1 minus r. So that's going to give you S sub n is equal to 48 over 1 minus 1/4. I don't like working with fractions within fractions, so I'm going to turn it into division. So that's going to give us 48, or 48 over 1, divided by 1 over 1 minus 1 over 4. You cannot subtract those two fractions, so we're going to turn it into 4 over 4 minus 1/4, and that's going to give us 48 over 1 divided by 3 over 4. We're going to keep change flip because we cannot divide fractions unless we do so. So that's going to give us 48 over 1 times 4 over 3. 3 becomes 1, 48 turns into 16. You're going to do 16 times 4, which gives you an infinite sum of 64. For number 11, it tells you to find a sub 1 and a sub n, given that a sub 3 is equal to 5, and a sub 8 is equal to 1 over 625 of the geometric sequence. We're working with a geometric sequence, which means we're using a sub n is equal to a sub 1 times r to the power of n minus 1. We are going to use this a sub 3, or the 3, as 1, the 5 as a sub 1, the 8 as n, and the 1 over 62 as a sub n. And we're just going to switch these out to solve for r. So that means that we are going to have 1 over 625 is equal to 5 times r to the power of 8 minus 3. That 8 minus 3 is 5, so that's 1 over 625 is equal to 5r to the power of 5. We're going to divide each side by the 5 or multiply by the reciprocal. So that's going to give us 625 times 5. 1 over 3125 is equal to r to the 5th power. We're going to take the 5th root of both sides here, and we get that r is equal to 1/5. So for a sub n, that's going to give us the formula a sub n is equal to a sub 1 times 1/5 to the power of n minus 1. We still need to find a sub 1 though. So we're going to plug in the a sub 3 is equal to 5, 3 and 5 in for this to find a sub 1. So a sub n is going to be 5 is equal to a sub 1 times 1/5 to the power of 3 minus 1. That 3 minus 1 is 2, so that's 5 is equal to a sub 1 times 1/5 to the 2nd power. That 1/5 to the 2nd power gives us 1 over 25. We multiply each side by the reciprocal of 25, and we get that a sub 1 is equal to 125. So that's part of what it's asking us for. The other part is the a sub n. So if we take a sub n is equal to 125 times r, which is 1/5, to the power of n minus 1, that gives us our other part of a sub n. Your next sections come from the 13.6 lesson. So for number 12, you have this weird looking thing that says 18C5. That sub 18 and that sub 5 are the numbers that are going to be in your parentheses. It's just written for you in a different manner. So this would be your combination of them. So your 18 is going to go on top. The 5 is going to go on the bottom. And you are going to use the same formula you use with something like number 13. And if we use our formula, we're going to have 18 factorial over 5 factorial times 18 minus 5 factorial. And yes, that is a minus, not a times. So this would then simplify to give you 18 factorial over 5 factorial times 18 minus 5 is 13 factorial. So if you were to write this out using multiplication, you would have 18 times 17 times 16 times 15 times 14 times 13 factorial. It would just mean that it keeps going. And this is all going to be over 5 times 4 times 3 times 2 times 1 times 13 factorial. Your 13 factorial is the same on the top and the bottom. So from here, in your calculator, multiply this out. 18 times 17 times 16 times 15 times 14 gives us a very large number. 102,8160 over 5 times 4 times 3 times 2 times 1, which is 120. If you divide these two numbers, 102,8160 divided by 120, you should get 8,568. For number 13, you have 17 as your top number and 17 as your bottom number. So that means that you're going to have 17 factorial over 17 factorial times 17 minus 17 factorial. Your 17 minus 17 is 0. So that means you have 17 factorial over 17 factorial times 0 factorial. We said when we went over this lesson that 0 factorial is equal to 1. So that means that you just have 17 factorial over 17 factorial. Anything over itself is 1. For 14, you have 11 over 4. So that 11 is your top number. We'll have 11 factorial over 4 factorial times 11 minus 4 factorial. Your 11 minus 4 gives you 7. So that's 11 factorial over 4 factorial times 7 factorial. That 11 factorial is 11 times 10 times 9 times 8 times 7 factorial. The 4 factorial is 4 times 3 times 2 times 1, and then you have that 7 factorial. The 7 factorial is on the top and the bottom, so cancel them out. You have 11 times 10 times 9 times 8 on the top, which gives you 7,920. And then the 4 times 3 times 2 times 1 on the bottom, which is 24. If you divide these two numbers, you should get 330 as your answer. For number 15, you have a 9, C, and then 9. So to write this using your parentheses, you have 9 over 0, which means you're going to have 9 factorial over 0 factorial times 9 minus 0 factorial. We said that 0 factorial is just 1. So then this simplifies to give you 9 factorial over 9 factorial, which again is just 1. For 16, you have 216 and 211 for your subset numbers. So that 216 is going to go on the top. That 211 goes on the bottom. That means you're going to have 216 factorial over 211 factorial times 216 minus 211 factorial. Simplifying this, that 216 minus 211 gives you 5 factorial. So that's 216 factorial over 211 factorial times 5 factorial. The 216 factorial, we're going to go from 216, 215, 214, 213, 212, and 211 factorial over 211 factorial times 5 times 4 times 3 times 2 times 1. So in my calculator, I'm just going to do 216 times 215 times 214 times 213 times 212, because those 211s cancel. Put that over 5 times 4 times 3 times 2 times 1. And that gives us a very large number, which should be 373,972,9608. The last part of your review goes over using Pascal's triangle in order to expand the binomials. For number 17, we have x plus 3 to the third power. We're going to use the x to the third power, x to the second power, x to the first, and x to the power of 0. And then we're going to plug in the numbers from the third power row in Pascal's triangle, which is going to be 1, 3, 3, 1. And then we're going to use that 4 as 4 to the power of 0, 4 to the first power, 4 to the second power, and 4 to the third power. Your power of zeros, cancel them out. For your first one, you have 1 times x cubed, which is just x cubed. The 4 times 3, which is 12 times x cubed. That's 12x, or sorry, x squared, 12x squared. Then 4 squared, which is 16 times 3. That's 48 times x, is 48x. And then the 4 to the third power is 64. For number 18, we have y minus 3 to the fifth power. So we're going to start with y to the power of 5, y to the fourth power, y to the third, y to the second, y to the first, and y to the power of 0. Our power is 5, so we use the fifth row or the fifth power row from Pascal's triangle. So 1, 5, 10, 10, 5, and 1. Then our second term in that binomial is negative 3. So we start with the power of 0, the power of 1, the second power, third power, fourth power, and fifth power. Oops. Your powers of 0, we cancel out. We then have y to the fifth power. The negative 3 times 5 is negative 15, y to the fourth power. Negative 3 squared is 9, negative 9, sorry. Negative 9 times 10 is negative 90, y to the third power. Then your negative 3 cubed is negative 27, times 10 is negative 270. Keep the y squared. Next, you have the negative 3 to the fourth power, which is 81, times 5 gives us 405. Keep the y. And then that negative 3 to the fifth power is negative 243. For number 19, we have x minus 3y to the seventh power. Our power is 7 here, so we're going to start with x to the power of 7, x to the sixth, to the fifth, to the fourth, the third, the second, the first, and the power of 0. We're working with the seventh power here. So from Pascal's triangle, we are going to work with 1, 7, 21, 35, 35, 21, 7, and 1. Next, we have that negative 3 to each of the powers from 0 to 7. So negative 3y to the power of 0, negative 3y to the first, negative 3y to the second, negative 3y to the third, negative 3y to the fourth, negative 3y to the fifth, negative 3y to the sixth, and negative 3y to the seventh. I'm going to cancel out my powers of 0 and then start working this out. So we have x to the 7th power, which is x to the 7th. Then we have negative 3y times 7 times x to the 6th. Next, we have the negative 3y squared, which is a positive 9y squared times 21 times x to the 5th. Next, we have negative 3y cubed, which is negative 27y cubed times 35 times x to the 4th. Then we have a negative 3y to the 4th, which is positive 81y to the 4th times 35 times x cubed. Next, the negative 3y to the 5th power is going to give us 3 to the 5th is 243. So negative 243 times 21 times x squared and y to the 5th. Then we have the negative 3y to the 6th power. So 3 to the 6th power is 729 y to the 6th times 7 times x. And then we have the negative 3 to the 7th power, which is negative 2187 y to the 7th. So we're going to move all the way over to the front now of this and combine or simplify these. So that's going to give us x to the 7th minus 21 x to the 6th y plus 9 times 21 gives us 189 x to the 5th y squared. Then you have 27 times 35, which is 945 x to the 4th y to the 3rd. Next you have that 81 y to the 4th times 35 x to the 3rd, which is going to give you a positive 2835 x cubed y to the 4th. Then you have negative 243 times 21 times x squared y to the 5th, and that's going to give you a negative 5103 x squared y to the 5th. Next, you have the 729 times 7 times x times y to the 6th, which is positive 5103 x y to the 6th. And lastly, you have the 2187 y to the 7th power. From here, for number 20, you have x squared plus 2y cubed to the 5th power. So we're going to start with the x squared to the 5th power. Then we have x squared to the 4th, x squared to the 3rd, x squared to the 2nd, x squared to the 1st, and x squared to the power of 0. You're working with the 5, so that's 1, 5, 10, 10, 5, and 1. Then you have the 2y cubed to the power of 0, 2y cubed to the power of 1, 2y cubed to the power of 2, 2y cubed to the 3rd power, 2y cubed to the 4th, and 2y cubed to the 5th. So we are going to multiply this out, canceling out our powers of 0. We're going to have x to the 10th power plus 2 times 5 times x to the 8th y to the 3rd. Then you have 2 to the 2nd power, which is 4 times 10 times x to the 6th y to the 6th. Next you have 2 to the 3rd power, which is 8 times 10 times x to the 4th, y to the 9th. Next, 2 to the 4th power is 16 times 5, x squared, y to the 12th. And lastly, the 2y cubed to the 5th power is 32, y to the 15th. So from here, we just multiply, and we have x to the 10th power plus 10, x to the 8th, y to the 3rd, plus 40, x to the 6th, y to the 6th, plus 80, x to the 4th, y to the 9th, plus 16 times 5 is 80, x squared, y to the 12th, plus 32, y to the 15th. For number 21, which is our last one, we have 3x squared minus 5y cubed raised to the 7th power. So we're going to start with doing the 3x squared to the 7th power. Then we have 3x squared to the 6th, 3x squared to the 5th, 3x squared to the 4th, 3x squared to the 3rd, 3x squared to the 2nd, 3x squared to the 1st, and 3x squared to the power of 0. We're working with the power of 7, so we're going to work with 1, 7, 21, 35, 35, 21, 7, and 1. Lastly, we take that negative 5y cubed, raise it to the power of 0. Oops. Raise it to the 1st power, to the 2nd power, to the 3rd, to the 4th, the 5th, the 6th, and the 7th. We're going to cancel this out. We have 3x squared to the 7th power. That 3 to the 7th power gives us 2,187 x to the 14th. Then we have negative 5 times 7 times 3 to the 6th power, which is going to give us negative 25,515 times x to the 12th, y to the 3rd. Next we have negative 5 to the 2nd power times 21 times 3 to the 5th power, which gives us a positive 127,575 x to the 10th, y to the 6th. Next, we have negative 5 to the 3rd power times 35 times 3 to the 4th power, which gives us a negative 354,375 x to the 8th, y to the 9th. Next, we have negative 5 to the 4th power, which is positive 625 times 35 times 3 to the 3rd power, which is 27, which gives us 590,625 x to the 6th, y to the 12th. Next, we have negative 5 to the 5th power, which is going to be a negative 3,125 times 21 times 3 squared, which is 9. So that's negative 590,625 x to the 2nd. No, x to the 4th, I'm sorry. X to the 4th, because it's the 2nd raised to the 2nd power. So that's x to the 4th, y to the 15th. Then we have negative 5 to the 6th power. So that's the 15,625 times 7 times 3 to the first power, which is 328,125, x squared, y to the 18th. And lastly, we have that negative 5 y cubed to the 7th power, because that 3x squared to the power of 0 cancels out. So that negative 5 to the 7th power gives us negative 78,125 y to the 21st power.